Hello, welcome to another exciting lecture on inferential analysis, and today we are looking at hypothesis testing. I am Michael Powie. The first question is, what is hypothesis testing? And before we look at the process, we want to define what hypothesis is. A hypothesis is simply a claim about a population parameter, or in basic terms, a claim about an unknown value of a population parameter or a population value. Good. So in short, we can say it is a verbal statement or a claim about a population parameter. For example, the farmer could claim that its new malaria treatment will cure patients in less than 5 days. This is a claim made by the manufacturer of this drug. Okay, and such a claim could be false or could be true, which means that there is a need for us to experiment. Then the process of experimenting using sample information is what we refer to as hypothesis testing. Hypothesis testing is the process that uses sample information or sample statistics to test a claim about the value of a population parameter. Example, a manufacturer could claim that its rechargeable batteries have an average life greater than 1,000 charges. Then a random sample of 10 batteries can be selected in an investigation to determine the mean, and it has a mean life of 1,002 charges and a standard deviation of 14. So the question is there enough evidence to support this claim at a significance level of 0.01, assume normality of the population? A second example, a farmer claims that its new malaria treatment will cure patients in less than 5 days. A random sample of 15 people who took the medication shows an average of 4.8 days. So you see that a claim can be made by a manufacturer, and then hypothesis testing is the process of testing the claim using information from selected sample. Steps in hypothesis testing. There are basically 5 steps which we can consider in hypothesis testing. Step 1, to state your null and alternate hypothesis, and we'll be explaining that briefly. Step 2, to select a level of significance. Step 3, identify the test statistic. Step 4, formulate a decision rule. Step 5, take a sample to arrive at your decision, and then you make conclusions, either to reject your null hypothesis or fail to reject the null hypothesis as your final conclusion. Good. Now, let's look at the first step, stating our hypothesis. So when we are given a claim, like what we have here, it says a manufacturer claims that its rechargeable batteries have an average life greater than 1,000 charges. Okay, how do we write the claim? The first step in writing the claim is to rewrite the statement mathematically. Mathematically means you have to identify which mathematical notation would accurately represent the given statement. So the key statement here is its rechargeable batteries have an average life greater than. So we need the greater than notation, and average is also the mean, so you need mu. So we are talking about mu greater than 1,000 charges. So this can be written as such: mu is greater than 1,000 charges. Then the second step is to write the opposite or contrary statement to this, because we said the given claim could be true or false. So once it is made, you have to write a contrary statement to it. And the opposite statement of greater than 1,000 charges is mu is less than or equal to 1,000 charges. Then the final step is to determine which one is the null and which one is the alternate. And to do this, let's go to the next table, which will assist us to understand better. Now we have a table here which will guide us to how we can represent our null and alternate, and also identify which statement is the null and the alternate. So you could see in the second column here, we have H1. These are the alternate hypothesis statements of the alternate, that is H1, and then we also have the statement of the null hypothesis. If you look at the third column, you will see that all the signs have an equal to associated with them. So for example, mu is greater than or equal to a stated mu naught, mu is less than or equal to, and then mu is equal to. So anytime we have an equal to in our statement, then that statement is a null hypothesis. On the contrary, if the statement does not have an equal to, then it is the alternate hypothesis. Another interesting thing this table shows us is the direction of the test. When we are dealing with mu less than mu naught, then we are talking about a left directed change or a left hand test. Then if mu is greater than mu naught, we are talking about right directive change, or what do you call as greater than, or a right hand test. And then mu is not equal to could be less than or greater than. So we have a two-way test. Now let's take another example and make use of the table to understand. It says Kinepharma claims that the new drug, the new malaria treatment, will cure patients in less than 5 days. So we are talking about the average recovery period is less than 5 days, which means we write mu is less than 5 days, and the opposite statement will be mu is greater than or equal to 5 days. Okay, so the second statement should be greater than or equal to 5 days. Now, which one should be the null and which one should be the alternate? The second statement becomes the null, that is H0, because it has the equal to in it, whilst the first statement becomes your alternate hypothesis because it does not have the equal to statement.